Welcome to our penultimate module. We've explored supervised, unsupervised, and now generative AI. But there's a third major paradigm of machine learning, reinforcement learning, RL, the science of teaching an agent to make optimal decisions through trial and error in an environment. Think back to how a child learns to ride a bicycle. They don't have labeled data, and they don't just mimic. They try, they fall, they get a scraped knee, a penalty, they adjust, they try again, and eventually they learn to balance, a reward. RL works similarly. An agent learns to perform a task by interacting with an environment and receiving rewards or penalties for its actions. The goal of the agent is to learn a policy, a strategy or mapping from states to actions that maximizes the cumulative reward over time. It's not about immediate rewards, but about long-term gain. This makes RL particularly powerful for sequential decision-making problems. Unlike supervised learning, where you provide explicit input-output pairs, in RL, the agent discovers the optimal behavior itself through exploration and exploitation. It tries different actions, observes the consequences, and updates its strategy based on the feedback it receives. This paradigm is what enabled AI to defeat human champions in complex games like Go and chess. And it's driving advancements in robotics, autonomous systems, and even financial trading. It's about learning through experience. In this lecture, we'll cover the fundamental components of an RL system and some core algorithms. Let's start with the key concepts that define the RL framework.